Hello, good afternoon. Wow, that was loud. So thanks for coming out here. I know you had a lot of sessions to choose from. I appreciate you choosing this one. My name is Bill Barnes. I'm a developer in the Developer Experience Group. And that means I get to sit down and code with partners, with developers from companies big and small from around the world. And we learn a lot when that happens, and we feed that back into the product teams. And so that's what we're doing today. In part is to tell you about cognitive services, and in part to get some feedback. I'd love to chat with you guys afterwards if you've had any experiences with it. I have to tell you that I love my job. It's maybe the best job I've ever had. I might love it more than my children, don't tell them. But there's one thing I fear, and that is when somebody says, we'd like you to give an overview of Azure. So here's Azure. At this point, giving an overview of Azure is like giving an overview of the internet. Like just if you could just go over all the websites, that'd be great. At this point, Azure is so big that just to list the names of all the services would take about an hour. And can we just take a second and feel sorry for the poor graphic designer who had to come up with a different icon for each of those things? Some of them make sense, and sometimes it's like Data Lake Analytics Service. All right, it's a rectangle with a lightning bolt. Just go with it. So today we're going to focus on that little part up there that says cognitive services. Even cognitive services, 6 months ago, this would be a short talk, but even cognitive services, it's getting kind of big. There's a lot of stuff going on there, but it's okay. We actually do have time to talk about all of it in an hour. Here's the thing about cognitive services. Most of you guys are at the keynote. Cognitive services demos like crazy, right? Because it's magic. You know, he aims a camera at the table and it says, I see a pair of scissors. Everyone's like, oh my God, it's a pair of scissors. It's right. How did it know that? We could spend all day just doing demos of cognitive services, and it would be ooh and ah, but you wouldn't learn very much. So we're going to be light on the demo side today. I decided I would rather spend the time going deep into the technology of it. So, however, all those demos that you saw are actually available as an app in the Microsoft Store called Intelligent Kiosk. And I thought you could bring your own demo. You could load it up. Actually, the sources are on GitHub too. Load it up, show it to your families and friends, be a magician. It's amazing. So I invite you to do that. So in terms of how to think about cognitive services, it is helpful to understand this. Now, first of all, who was at my bot talk earlier today? Okay, so you guys know the answer to this. Everybody else, what do those numbers represent? Anyone know? So those are number of transistors on a microchip. So this is Moore's law. And the funny thing about this particular timeline is that it starts in 1995 when Moore himself had pretty much disavowed his own law and said, you know, look, there are physical realities, there are laws, there are manufacturing realities. It was a great run, but it's clearly over with now. But it wasn't. It kept on going. And so what started off with the population of New Zealand on a chip, 10 years later was the population of Bangladesh. 5 years later was the population of India. 5 years later, the population of the world. But the thing that we notice, and sorry, yeah, if you're at my bot talk, about 20% of this talk overlaps with that one, so you guys can read your mail or something if there's a slide you've already seen. The question we ask is, so in 1995, that's roughly Windows 95, right? And that made the desktop interface ubiquitous. It's still essentially the same interface we have now, right? It's got gradients and transparency and better multitasking, but it's still recognizably the same interface. 2005 was about when the iPhone came out. And we had this new interface of moving little colored rectangles around a piece of glass. That too is about the same now than it was then. But we have almost 2 orders of magnitude more computing power. What's happening to all that computing power? Like, what's it doing? Well, everything from 1995 and 2005 fits in that little bit there on the left. What is all that computing power going to? Well, it's not powering these 2D interfaces. Partly it's powering the next generation of 3D interfaces, right? VR and AR, these immersive experiences. But what we're going to talk about today is what my friend Rick calls 1D interfaces. It's powering the cognitive services, the artificial intelligence that allows computers to understand our voice, understand our words, understand the world around us, and often not even really need an interface when we talk to computers. And so this leads us to AI, or I have to tell you the story, which is last week I sat down to breakfast with my wife, and she said, so what are you going to be talking about in New Zealand? And I said, I'm going to talk about bots. You know, bots are all I do. And I'm also going to talk about cognitive services, which is, you know, computer vision and voice and text. And she said, oh, does it use AL? And I said, what do you mean? She said, AL. I've been reading that a lot of software uses AL these days. And I said, do you mean AI? She's like, no, I'm pretty sure it's AL. And she figured, you know, there's Siri and there's Cortana, and there must be Al as well. So I have her permission to tell that story. And I apologize because now whenever I see this, I can't not see Al. So today we're going to be talking about Al. Just a very, very brief piece of history, which is when I went to university at Carnegie Mellon in the late 80s, the basic philosophy about Al was that we would teach computers. We would teach them grammar and syntax and meaning, and because of that, they would finally understand language. And there was self-driving cars, and we would teach them about edges and blades of grass and whatever it took to do that. And that fell out of favor. And now, as a parent, I understand why. Because I did not teach my children, English through sentence diagrams. You know, we just talked around them, and then they had this amazing feedback cycle of hearing how stuff went and trying stuff and seeing how it works. You know, and so it wasn't a process so much as us teaching them as them learning from all the data and inferring the rules themselves. And this, as it turns out, is how it works. This is how we teach computers, is we don't teach them at all. We give them enough data, we give them a little guidance, and it learns. And what that took between the 80s and now was advancements in several areas. First was just tools. Tools like convolutional neural networks, which are a big deal. But along with the tools, almost as important, or maybe more important, are actually the techniques and how we use them. And when we see big advances, it's often not because we have some incredible new technology, but now we have figured out a different way to slice the data, right? So it turns out the grunt work is just as important as the whiz-bang work. And more importantly, and this was touched on a bit in the keynote yesterday, is just the data. That we had neural networks back in the 80s. It's just that when we fed the neural networks hundreds or thousands of units of data, it didn't work very well. But now we feed it millions, billions, hundreds of billions of data, and suddenly everything changes. And we simply didn't have that kind of data collection capability back then. We couldn't even transmit data like that back then. So things have really changed, and the internet has enabled that. And of course, in order to make all this stuff happen, you need computing power. Because to build all these models means trying all the stuff that doesn't work before you find the one thing that does. And so all these things had to advance until we got to where we are today. And that's why this is all exploding now. Like, there's a good reason. We actually needed to have all that computing power, all that data. We needed to have the internet, in fact, to power the Al revolution. And so, and stick with me, because this is a little goofy and a little cheesy, but I think it's true. We started off thinking that we needed to teach the computers things, and we've discovered that what is better is to let the computers learn. But I think what's interesting is we started off thinking we had something to teach computers, and increasingly I think we find that we have stuff to learn from computers. It's a little cheesy, but it's true. So if you were at anyone at Jennifer's talk? Yes, she's a hard act to follow. Thanks, Jennifer. So I'm going to go a little bit over machine learning because this helps inform so much of what cognitive services is. About 9 out of 10 of the cognitive services are powered by machine learning. So first of all, it's about data. It's often about a lot of data, but more importantly, it's about high-quality tagged data. Someone came up to me after the bot talk and said, we have all these records of chats with customers. Can we use that to train our models? And I said, well, probably not. I mean, are these records tagged with outcomes or anything? He's like, no, they're just records. And so that's not helpful. What's helpful is if you have records of data and along with that record is, and this led to this following resolution. Well, that's something you can use to train models, but just the data by itself doesn't really help you. And then the strategy, the techniques. What algorithms do you use? How do you slice and dice the data? How do you extract the features from the data? And that's that part, which is this data, text and stuff. Often it's noisy. Often there's a lot of stuff in there. In Jennifer's example, when she's doing her EEGs for lie detection, there's lots of brain waves, but we don't really care most of them. A lot of them are just person listening to the question before the person is going to lie or tell the truth, and she wants to capture that moment when they decide to lie or tell the truth, and that's where the data is. And so you have to exclude all the rest and capture those features. And then you need to compute a lot. And it turns out that you don't need a CPU, you need a GPU. It turns out, and this is kind of funny, and I don't think anyone planned it this way, but these graphics cards that were developed to help us explode aliens are the things that are helping us understand the world around us. And so, funny turn of fate that if what you want to do is do a lot of machine learning, you basically just do the most bitchin' graphics gaming machine you can, and that's a machine learning machine. And the result of all that all that computing of trying every single path to find one path that gets you from the data to this classification is what's called a model. And that model does a good job, by definition, of the one that works is the one that takes that data that you fed it and classifies that stuff into buckets. So for example, if your task is to decide whether a photograph is a person, a happy person or a sad person, you would start off with this data, a bunch of photographs that you've previously decided are happy people and a bunch of photographs that are sad people. And you would use that to generate your model, and then you'd run all that data through again, and it would correctly classify them. But here's the problem. You can do this thing called curve fitting, which is that the algorithm you have is essentially purpose-built just for the input data. Because one algorithm that would work in that case would be an algorithm that says, if image is one of the happy photographs, then classify as happy. And that works until you add any new piece of data, and then it doesn't work anymore. So you have to test it on new data. So what happens with that first data that you got, that data tag, is you divide it into groups. You use the first one to train the model, you use the next one to test it. You often use another third even to test it again. Because you keep wanting to go through this until you have a model that reliably works with new data and classifies it. So you have to keep repeating that until you have successfully got a model that does that. And still you are not done, because we always want our models to be better. That's part of it. But part of it is that the act of running the model on new data yields opportunities for more tagging. So now if there's a way that you could run new data on this stuff, oh yes, this is a happy person or this is a sad person, and have a human saying that's correct or that's incorrect, now you can feed that back into the cycle and train the data and get it even better. And so in a way, it never ends. You just keep doing it. And this is how I think about it, that it's an iterative process. And we kind of take turns teaching the computer, but we also take turns learning from it. So to go back to the face thing, the face, Microsoft has an API, which I'll demo in a little while, called the Emotion API, which is to take a face and actually tell you what are the likelihoods that this person is happy or sad, surprised, and so forth. There's 7 or 8 of them now. And in order to do that was a process of kind of building on levels of first recognizing the face. It's pretty important to get the face, because if your motion model is like looking at the hair, it's going to do a pretty bad job. So we want to make sure it's got the face. And even within the face, it turns out to be really valuable to identify certain features. One of the things I find fascinating about machine learning is often that I don't know how I do things. Like, I don't know how I tell if somebody's happy or not. I mean, I can tell if they're smiling, but you know the fake smile, right? It's a fake smile. How do we know it's fake? Well, the mouth's doing one thing, and something's going on with the eyes, but I don't really know if I could tell. But a computer actually does know. And you can look at a classification and look at a heat map and see what the computer's actually looking at when it makes a decision. And from that, we can learn. And over time, what we've learned is that we can divide the face up into these 27 points. And if it can find these 27 points, and it can, and then it can look at them in relation to each other, these are the features that you extract from the data, then it can tell you what emotions. It can also make a pretty good guess as to age and gender and facial hair. We'll talk about it. So this is machine learning. This is how it's done. And you saw, if you were here for Jennifer's thing, you saw that what she used for her lie detection using her Magic EEG helmet was a thing called Azure Machine Learning, which is a service to let you do this stuff. Now, I'll tell you, the real machine learning experts, the data scientists, they don't use stuff like this. They have their own toolkits. A lot of it is open source. They have these tool chains. They're totally happy with that, and we're not trying to get in the way of this. This is, and I don't mean this in any way a demeaning way, this is the Visual Basic for Azure Machine Learning, right? And Visual Basic is this tool that it's easy to make fun of the people who use Visual Basic, but let's face it, we got a lot of programming done with Visual Basic, and a lot of people who used it who weren't computer scientists got a lot of work done. So that's what this is. This is for people who are working in companies who have data. They want to do stuff with it. They're not going to hire data scientists. They just want to get some jobs done. And it's great. It shows flow charts. It really kind of walks you through it. And the best thing is when you're done, it can expose your model as a REST endpoint. So if you have your own model for, in Jennifer's case, lie detection using an EEG helmet, she can actually publish that for the world to use if she wants. And that's pretty cool. And something that has breaking so fast that I didn't have time to get into this deck is Microsoft has actually released its own proprietary, well, previously proprietary machine learning toolkit, CNTK, which I think is Cognitive Network toolkit. So it's our own tool chain that we use to develop a lot of the models you'll see. So that's now available for the world to use. To create these models, you need really good data. And again, a lot of that data needs to be at web scale. And so there are already relatively few companies who can do that in the world, and you know exactly which ones they are, and Microsoft is one of them. You do need a lot of expertise. You need the right tools and the right technology, and you need lots and lots of computing power, which means money, right? It's expensive. It's the hardware, the electricity is expensive. And I would say you need this last thing. You need the commitment to keep improving it, because what seemed like a pretty good voice recognition technology 2 years ago is now just trash, right? Because the technology keeps moving forward. So these things, when you're considering a vendor, you want to make sure they have that improvement. And I would say all the big companies have that. They're all very invested in it, but Microsoft is certainly one of them. And so what happened is that we had all this technology embedded in places at Microsoft. We had it in Bing. In Bing, you could do a search for pictures of happy children, right? And there's actually a lot going on there. First of all, there's probably natural language parsing of that phrase to find out what they're looking for. Then we have to be able to find children, pictures of children, and get their emotions. So just to solve what seems like a simple problem has a lot of different models going on. Same thing inside Cortana with voice recognition. All this magic existed that Microsoft Research had produced for Microsoft products, but you kind of couldn't get at it except through these products. And what has been happening over the last year is Microsoft has been unbundling all of these bits of technology, all of these models, and making them available just as APIs for anybody to use on an a la carte basis, which I would say kind of follows the Microsoft a la carte approach to everything. It used to be you had to be on the Microsoft stack completely or you weren't, and that was kind of a rough decision. And now it's just, oh, yeah, use the services you want. If you don't want to, that's fine, and we'll try to do better next time. And that's a lot easier as a customer to not have to make that decision. So cognitive services, here's the official blurb, motto, which is enable your apps to see, hear, interpret, and interact in more human ways. I actually find this slightly creepy. I think about it this way. It's an API for accessing the real world. And the real world is not a black and white place. The real world is supremely fuzzy. I remember going to Japan in the late 90s, early 2000s. Everything had fuzzy logic in it. The toilet seats had fuzzy logic. Your toaster had fuzzy logic. It was the big thing. This is fuzzy logic wrought large. We are now in the place where these APIs do not look like the APIs that we as programmers are used to. We're used to the APIs that say, do this and give me that data. And these APIs, the data you get back, they're like percentages. Oh, it could be this, could be this. Hard to say for sure, because that's how the real world is. It's hard to say for sure. Even we as humans, for the most part, cannot make, well, I even just did it, cannot make really solid yes or no sentences, for the most part. Everything's kind of fuzzy. And so that's how these APIs are, and it's actually it's a little weird to get your head around it. This is how I think about it the other way, which is that these are really hard problems that Microsoft has solved, so you don't have to. So we're going to talk about that. And it is unavoidably, with about 25 different APIs, it is kind of a long list of stuff. And so you're just going to have to stay with me. It's really amazing magic that goes on, but there's not a unifying narrative and theme that goes through with it that makes it kind of really easy to talk about it in a super engaging way. I'm just kind of warning you, like when I was putting this talk together, I'm like, wow, what's the really fun thing I can do about cognitive services? And aside from the kick-ass demos, which do take up a lot of time, sometimes we're just talking about APIs. So that's what we're going to be doing. We're going to be talking about APIs. And I won't go deep into the APIs. We won't, for the most part, like go into the REST signatures and stuff. So they're categorized into this group. And here's a few things I have to say about the cognitive services APIs while I'm giving you caveats. One is that I personally am unlikely to know the details of the pricing. It's available on the websites. I can never remember which languages are supported by which things. It's on the website. Sometimes the details escape me. I have used some of these extensively, and some of them I only vaguely understand. So we're in this together. Maybe you can explain it to me. Some of these APIs, I know exactly where it came from. You can like just tell, here's the product it came from. Some of it's like, huh, I wonder why we do that. And similarly, some of them I can give you really concrete ideas on what to do with this. And some of them I'm like, I wonder what you're going to do with that. So this is where I'm hoping for some interaction, maybe not necessarily during this, but I would love to hear from you afterwards if you have ideas, and especially if you have used some of these. Let me know what you've done with them. The other thing you can expect as we go through these APIs is that there's a certain amount of overlap. So these were often produced by different research groups. So for instance, the computer vision API that we'll start off with recognizes faces, but there's a whole separate and more targeted face API. And so there's a little overlap in that, and you'll see that. Also, some of them are kind of randomly assorted, which is basically marketers deciding that it belongs in this column and not this column, and the ways of marketers are unknown to us humans. What you can expect is that most of these APIs are available primarily as REST APIs, but a few are not, and I'll explain those, the exceptions. Also, almost all of these, especially the REST APIs, are available in pricing tiers. There's almost always a free level, with one major exception. And so that is great for experimenting with. Often the free level is pretty high, like 5,000 transactions per month, which is low if you're going to use it in production, but it's high if you're just playing around and want to see what it's like. And then it's just basically levels of numbers of transactions after that. Okay, let's talk about computer vision. So computer vision we saw at the keynote where he aimed a camera and it said, I see a pair of scissors. So computer vision's pretty cool. There's a lot of interesting models going on there. So one of the things it can do is, and I definitely have a cheat sheet here, I'm not going to try to lie. One of the things it can do is list all the objects it sees. So if you aim it at this desk, it would say, I see 2 monitors, 2 laptops, and a bottle of water. It'll actually list them individually, laptop, bottle of water, but then it'll actually produce a sentence, an English sentence, or actually a locale-specific sentence, describing the field as a whole, which I think is its own little bit of magic, just that it can describe it well. It can identify all the faces it sees. It can tell you whether an image is line art or like a photograph or clip art. And it can tell you whether there's adult content. And later on, we'll talk about a different API that's more specifically aimed at the adult content thing. There's also a new API, or new within that, is you can optionally ask it to describe any celebrities it sees. It strangely thinks our CEO is a celebrity, so I got trained on that one. So that'd be a fun, do you look like a celebrity sort of thing. We'll picture an audience like, we got a couple of George Clooney's. There's also an OCR, optical character recognition. So that is actually pretty good. And you can aim it at this, and you'll get the text on people's T-shirts. And it'll tell you what the bounding box is. And so now you can do a little bit of magic. Because you can take a picture, it'll tell you what all the text is in a bounding box. You can take that text, run it through the translator, produce new text that fits in the bounding box, plant it back in there. And now you have a magic translator. And so there's apps that do this, but you can actually do it yourself now. It'll also do thumbnails. Now thumbnails sounds like it should be easy, right? It's just shrinking an image to the right size. But in order to get, let's say your thumbnails have to be vertical. Well, it's actually, if your image is horizontal, how does it do that? It has some smarts about what is the most interesting part of this picture. So if you have a picture of, a person standing in a field, it'll actually center it around that person in the picture. So we talked a little bit about the face support. The face support is actually pretty extensive. And so at its base level, what it does is look at a photograph and identify all the faces in it. I don't know if it'll do this many faces, but it'll do quite a number of faces. It'll give you the bounding box of that face. And this is what's used for face swap technology. So if you've seen Project Murphy, which is this bot where you can say, what if Bill Barnes was Superman? What it does is it's using the face API to find my face and the rectangle. It's going to use the Bing image search to find a picture of Superman. It's going to find his face, and it's going to swap our faces and put it in there. So that's how that works. But you can also use this to identify faces. So as with several of these APIs, you can both use, actually it's 3 of them, I think. You can use identify or verify. So you can upload a bunch of people, of pictures of people you know, and then you can say, is this face in this group of people that I know? And it'll tell you whether it is. So that's identify. Verify is, I have a number of pictures of this person, and now here's a new person. Are they the same person? So this is being used by Uber for their, when they have a driver and a driver kind of logs in, it'll actually take a picture of his face, and it has to match their records. Now this is not security in depth, right? It's easy. You could probably just put a photo of them, right? It's just something that you might use that. You might use some speech recognition. You might use some other stuff. You might use a password. It's just another level of, if you're Tom Cruise in Mission Impossible, this is going to be easy to spoof. But it is kind of helpful. So with those faces, it will then guess at your age, your gender, which is a little problematic, the head pose, like what's the pitch yaw of your head, whether you're smiling, how much you're smiling, which cracks me up. Facial hair, do you have a beard, mustache, and sideburns, and how long are they? And what kind of glasses are you wearing, if any? So I find the gender thing, I think it's a time bomb waiting to go off. Not only do a lot of people not identify as gender binary, but there's a lot of men whose faces might end up looking like, women and vice versa, and they might be really unhappy about that, and I just think it's just going to make people unhappy, but it's there for now. So the Emotion API. You might ask, why isn't the Emotion API part of the Face API? I asked that too. You can actually, if you have a photograph and you've already discerned all the faces in it, you can pass those rectangles to the Emotion API and save it a step, so it'll be faster. So it's going to look at those 27 spots and it's going to do emotions. And here are the emotions it does. Anger, fear, happiness, neutral, sadness, surprise, and this is my favorite. Contempt and disgust are in beta. Let's look at the Emotion API. All right. There's me. I assume you guys can see my password. That's going to be awesome. Okay, so let's see, I've pre-made these queries. Let's actually look at this query while it's in our editor, easy to see. So I'm just going to use curl so you can see it. We've got an endpoint here. I'm going to tell it I'm passing it some JSON. I'm going to give it my subscription key. That's a secret, don't tell anyone. This is totally being videotaped, whatever. And then I'm going to pass it the URL of an image. In this case, I've already uploaded images of my face. Oh, I forgot to show you. It's important. Okay, here's happy, sad, and surprised. All right, so that's what we're going to be passing in. So I've already uploaded those. I could also base64 encode them and pass them directly, but it's a little easier to do it this way. So I'm going to take this and run it in my command line, and it's all going to work beautifully. Okay, nice. No JSON object could be decoded. This worked 5 minutes ago. Here, I'm just going to run it again. Are we online? Oh yeah, I'm not connected. So, what happened to our magic? Bottom one, there it is. All right, thank you. Do I have to go through some auth or is it just open? We'll try it now. There we go. Sorry about that. You know why? Because I tested it in the other side, which has different internet. Yes, thanks for walking me through it. I need the help, clearly. Okay, we're almost there. There we go. Okay, one more time. That's promising. This is, I think, going against the West Coast US, so it's a little long. So I sent it the URL of the happy, and this is what we get back. We get that face rectangle. Again, I could have passed it in if I had it already. And you can see, here's the fuzziness. You can see it's making guesses at all of these. Now, none of them are particularly close, right? Happiness got 0.9999997, and everything else is in the many, many zeros. So this one wasn't close. So let's run sad. So sad's a little more ambiguous. It gives it 67% sad. Neutral might be close to 20%. Fear, disgust, they're all sort of possible. So there we are. I would say it's not that close, but it's a lot closer. And then let's look at surprised. This one is pretty sure of, 99+%. I'm not going to go through the APIs in all of these and curl them all. They kind of all look like this. You're typically posting JSON in a body and getting back JSON in the response. You've got a key. You provision those keys ahead of time. Almost all of them, as I said, have a free layer, and then you can always upgrade them. So. So that's Emotion. So video is kind of a toolkit for handling video. You upload a video, you either upload a URL to a video, you can upload the video in a big chunk. There's video for detecting and tracking faces within a video. Why isn't that part of the Face API? Why indeed? Actually, the Emotion API does allow you to upload video. So this is a weird marketing thing which we cannot question. There's video that does motion detection. So I recently visited my sister, and she just remodeled her house in New Orleans, and she lives kind of in a dicey neighborhood, so she installed all these closed circuit cameras, and they're totally engrossing. Like, she's got 4 of them, and her TV, by default, if there's no TV on, just kind of splits it and shows them all. And we would sit for hours and just watch the video of people walking by, and I don't know, there was something about it, it was hypnotic. And actually, the video was pretty smart because there was a little sort of flag on it that was green, and whenever there was enough motion, it would turn to red. And you could just tell there was some sort of interesting thing that probably got sent to her security service. But even then, that was overkill because those are just people walking by on the sidewalk. What she really only cared about was kind of the part of the screen that showed her property, and it was just hard to get the camera angle just right. So this API actually lets you upload video and define hotspots and say, tell me if there's motion in this area. And so that's a little more specific and a little more useful. And so if you're that company and you can do that stuff, this is a service you can use, right? You can just immediately outsource a bunch of that stuff. It will also do stabilization. So it'll actually feed you a new video, a stabilized version of the video. So it's not like earthquake or riding on a cruise ship stabilized, but it's walking along, you know, with your camera stabilized. It'll also produce a thumbnail. So we talked about how the Image API can do a smart thumbnail of a still. This can do a smart thumbnail of a video. First of all, it could be a still, but it actually produce like an animated GIF. And you can even tell it how many scenes. It's almost like a little trailer of your video, which is pretty smart. It'll even do a really cool fade in and out. Yes?
So if you wanted to do streaming video, is there an option for that, or you just upload small chunks?
This one is mostly small chunks right now, but there are other video, we'll talk about it later, but there are some APIs where you can actually stream it. And just so you know, the way this works with REST is you upload a video, and then essentially there's a callback. I mean, you kind of poll, and it gives you updates as often as you want to poll as it's processing the video. So speaker recognition is voice recognition. And this is not unlike the face recognition. It's the same idea. You can identify or you can verify. And so there's 2 levels where you can establish all these profiles, and it's something like 1,000. You can establish profiles for 1,000 users. If it's for identification, the way you train it is with just a single phrase. Just say something, and somebody says something, and it's trained. That's not enough for verification. So there's a higher level if you want to verify that somebody is someone from the list, again, for security purposes. In that case, there's actually a phrase list they provide to train people on, and they have to do a number of different phrases because they have a higher level. There is, in both this and the face recognition API, there's a little artfully crafted message from our legal department. And it basically says, don't use this to protect your corporate assets. I mean, it's voice recognition. It's pretty good. The face recognition is pretty good. And it's not that good. It's part of a whole scheme that you might use, and so you've been warned. So then there's speech. Speech. Microsoft just announced that its speech recognition now beats human speech recognition in terms of like transcribing speech and stuff. I believe that, and speech is not where I want it to be. It's not where I want it to be from any vendor anywhere, and it's not where I want it to be from Microsoft. Speech is one of those things that can work well when you have really good microphones, when you have a lot of control about your environment, when the person talking does not have a strong accent, whatever that means, because of course, whoever you are, you don't think you have a strong accent, and you're right. All those things is that if you think about it, it's very, very hard to build a model to understand someone speaking English when there's so many versions of what someone speaking English even sounds like. And again, that's in a controlled acoustic environment with good microphones. If it's somebody talking on a telephone from a car, all bets are off, right? And that's how it is. If you try to use any of the speech recognition stuff, it works well right in the middle. As you go to the periphery, it gets worse and worse and worse. Microsoft has a customized version of this that is in development. It's currently by invitation only. I am one of those people who can help you get an invitation if your company is interested in looking at that. So it's called CRIS, Custom Recognizer Identity Service, Intelligence Service. And it's about customizing a model to a specific acoustic signature, accents. A 911 call center in Dallas is going to have really, really different types of voices calling in than one in Oakland, than one in Auckland, than one in London. And so this helps you customize it for those situations. I'm looking at the time, and boy, time goes quickly, so I'm going to have to speed up a little bit. So that's speech to text. I don't love it. It's good for some stuff. Don't rely on it for everything. It's kind of where it is everywhere. This is one of the APIs that there is a REST API, but there's also a streaming version. To use the streaming version, you actually have to use a client SDK. REST isn't really up to that. So there's one for iOS, Android, Windows, and I think there's now a JavaScript client API for that, for doing it from a web page. There's also text-to-speech. Text-to-speech works well. And there's integration with our language understanding, with our natural language parser, so that the speech-to-text can then be run through LUIS, which I'll talk about in a few minutes, which can then parse that and derive intents from it. But I'll tell you what all that means in a minute. Text analytics is currently my favorite API. I don't know I could have a favorite API, but I do. So it does several things. One is you can get a body of text. It's usually like a paragraph. That's kind of what this is aimed at. It can tell you what languages it is. It can extract the key phrases from it. So for example, my mom is one of these people who can use a lot of words to say very little. And interesting, I sort of grew up to be the other way around. I'm often quite terse and concise. And so I have this dream that I'm gonna, because when my mom calls and she starts telling a story, there's just no knowing how long it's gonna be. And it's often not a very interesting story. Like the story is, I took my dog to the vet because she was sick, but she's okay now. But somehow it's a lot more words. So text analytics can actually extract out the key words. If I ran that through speech to text and then ran that through text analytics, it would say something like, sick, dog, better. And my idea is I could just have that thing running and I could be writing code, and then when I hit the silence, I'd hit the button, and then I could be like, I'm so sorry to hear that your dog was sick, but I'm glad it's better now. So that could solve a real problem for me. You can also run it on a whole corpus of documents, like thousands of documents, and it will tell you what the key topics are across all of those in order. But my favorite one is the sentiment analysis. Sentiment analysis is, I'm gonna tell you how positive the language in this is, from 0 meaning very negative to 1 being very positive. This is something we've seen in demos a lot, is like pull any review from TripAdvisor, and it'll tell you whether it's good or not. And if you can also track the keywords, that's pretty cool. There's a great demo in that intelligent kiosk where what it'll do is track, it'll take a whole bunch of data as input, and it'll track the various keywords. And it'll tell you people are positive about it, but they're feeling negative about the quality of the toilets, but they like the restaurants. I mean, it's kind of fascinating to see that stuff, and you can see the business implications. We have a guy named Matt, who I work with, and Matt is universally perceived to be grumpy. He's a grumpy guy. You can get him to rant about anything, but he doesn't think he's grumpy. So someone accused him of being grumpy the other day. He said, I'm not grumpy. So he actually ran text analytics on his own emails, and he determined that he was 52% positive, which meant he was slightly more positive than negative, and so he vindicated himself. Let's actually have a quick look at text analytics here. This is the last time we'll do the API thing. All right, so the text I'm going to run is, this is the worst talk I've ever seen. Okay. This is the one that's going against West Coast. So it gave it a score of 0.13, so quite on the low end, so recognize that being pretty negative. Let's just, I realize this is a simplistic example. So that one, 80%, pretty positive, right? Works incredibly well, surprisingly incredibly well. The example I used when I was talking about bots this morning is that text analytics is not something you'd use directly when having a bot, but if, let's say you've now automated part of your customer service system. People can talk to humans or people can talk to bots. If they're talking to a bot and you're running text analytics kind of in parallel, you can see if people are getting a little irate. They're sick of talking to a bot, it's starting to come through, they're starting to use certain words. Now you can be like, tell you what, let's connect you to our human, right? That's a nice opportunity you have to do that automatically. I'm going to go through the next half of this a little more quickly, which reflects the fact that I've used this stuff a little bit less. And also, especially in the knowledge area, a lot of it is kind of inside baseball for research. Because these are researchers. Researchers make tools for researchers, like first and foremost. And they think those are fascinating. The rest of us are like, I don't get it. So Bing spell check is spell check. And it kind of has two modes. It actually labels them this way. One is like using Microsoft Word. And the other is like using a search engine. And it's interesting, but there are two modes. There's spell check like you would find it in using Microsoft Word. You expect it to make kind of mild spell checks. But then there's spell check like you would use it in a search engine. Like you use a search engine and I type BART framework, right? Those aren't misspelled, but the search engine says, wait a second, I have a lot of knowledge of the things that people look for. Do you mean bot framework? And it says, do you mean bot framework? And in fact, it'll tend to preferentially list that. So that's the search engine mode. And so this lets you do that. This lets you issue a query, issue some text, and it'll kind of correct it more or less aggressively, depending on which mode you use. This is one of those things I'm not sure where it came from. I mean, it came from Bing. The web language model is Bing has indexed a lot of words. It knows more about how people use language than almost anyone else. And so it can use that to do some very sophisticated analysis of text. It can tell you, you can give it like 3 words used in 3 words, and it'll tell you, are those 3 words ever really used together? It can tell you, here's a bunch of words, what's the next word that's most likely to pop up? This is one that I find kind of fascinating, but I'm not sure what to do with it, but we can brainstorm it. It can take a series of text that has no spaces, and it can break it into words. So that actually would be nice if you wanted to analyze hashtags. Hashtags are often a bunch of words smushed together, and it could like break them up for you. That would also be, you could make one of those little keyboards on iOS or Android. You could have a keyboard that you don't have to type spaces because it would break it up for you, and it would predict the next word for you. So these are very kind of atomic operations that have a lot of interest in them, and someone is going to do really interesting stuff with them, and I have no idea what. Linguistic analysis is one of the few APIs that is not based on machine learning. It's not based on big data. It's old-fashioned syntax. It's a parser. It's a parser for languages. It's got several languages it knows how to parse. Sometimes that's very, very useful, and so this is just an API that does it for you. Literally sentence diagramming. So this is, language understanding is LUIS. It's our language understanding intelligence service. If you're at my bot talk, you're about to see a few slides you've seen before. Sorry, good chance to read your mail. Here's how natural language works. We've got multiple ways of saying the same things, and we want to collapse them so all those multiple ways look the same way. Tiago, I didn't even change the text. That's how lazy I was. But this was the bot talk. Tiago was doing the next talk on bots, and I wanted to tell him I was going to have a little bot that would send him a message saying I'm doing a great job. That's one way I could phrase it, but I could also phrase it this way. They mean the same thing, and that's the important part, because what they're going to map down to fundamentally is a method call called send message, and it's going to take 2 parameters, a contact and a message. That first thing, the method call, that corresponds to what is called an intent. It is our intention. It's reflecting what we want of this thing. Whichever words we use, that collapses down to our intent. I'm going to make this joke again. The next thing is called entities, because they had to call it something. Thingies was taken, I guess, but those are the parameters, basically. And so LUIS takes that text and breaks it into those 3 things. It breaks it into the overall intent and the values of those parameters, those entities. And it doesn't matter if you use different way of phrasing it. It knows they're the same thing. And not all the pieces have to be there. It can know that you're missing one or the other, or in fact both. And that's where bots kind of kick in, because if you're missing those entities, that's when the bot would probably start prompting you, who do you want to send it to? What message do you want to send? So that's how natural language works. The way you would train it, and we're not going to actually go into LUIS, but I'm just going to tell you the way you train it, is you feed it a series of phrases. And actually, you don't need to do very many. 5 or 10 often is good enough. What you want to do is come up with all the different ways you can think of to phrase that concept, that intent. And then it will produce a model, an algorithm that recognizes all those things as being the same intent. But you're not quite done when doing this, because it's a classifier, which means it has to sort things into buckets. You need to give it something to push against. You need to tell it what's not a send message. So in this case, what we did is we created a second intent called set reminder with several options there. And so now it could classify everything into one or the other. There's also a null intent. So that's how natural language works. And a lot of these, several of these APIs actually allow you to link directly to LUIS. so that you can take, for instance, spoken text, turn it into text, run it through an intent, and then do something based on that. The translator. The translator is interesting. I did a little spelunking in the translator because the translator, even though it's listed here on the Cognitive Services thing, it's not actually there on the Cognitive Services site. It's a whole different part of thing. It's in Azure. The only way to access it is via subscription. It's like it's from a different era, and that's because it's from a different era. Like Cognitive Services was this extraction of a huge amount of stuff out of research, out of products, and they just gave everything the same approach, the way you get keys, the REST APIs, the pricing structure. It's all this kind of transactional thing. You can really just tell that translators from an era where Microsoft was trying to figure out it's for enterprise customers and stuff like that. Translator absolutely belongs with everything else, and I believe that it's going to kind of move in that direction, but right now it is frustratingly behind this giant, you have to have a subscription to use it, without even any details. It's so enterprisey. It's kind of funny, except it's sad. So here we are in what I call inside baseball. Academic knowledge is a part of Bing that is basically crawling academic papers and doing various sorts of analysis. So you can do analysis like, how many citations did this researcher do per month? It's not the sort of thing I do, but it's the sort of thing researchers do. It's very specific. What's that? Can it do plagiarism? Can it find plagiarism? Is that what you're asking? It's the sort of tool you would use to sort of dig into that kind of stuff. Absolutely, yeah. So entity linking is actually, I believe it belongs more as a text analytics thing. It's actually pretty cool. So it takes a body of text, and it lists the entities in it, and it's very, very sensitive to, let me give you an example. A sentence I made up was, I can't count the times I read the Times at Times Square. So times means 3 different things, and it is smart enough to know that those are 3 different things. And so it gives you a list of the word times and where they're used, and it actually has references for things like the Times. It'll assume you mean a newspaper, and it'll give you a Wikipedia reference, and same thing for Times Square. So it has some knowledge of what things are in the world and how they show up in the text. The knowledge exploration service, really fast because I don't know that much about it. If you have really structured data, this is a research thing. If you have really structured data, like a research paper, where you control a lot of the stuff, this is a way of inputting this into a system and essentially crawl it and do some analysis of it. That's all I know about it and all I have to say about it. Okay, here's one of my other favorite APIs. It's the Recommendatio Ns. It's funny, the font size changed. So I actually tried to do this a while back. I'm a cartoonist. I have 2 comic strips. They have several thousand comics each. I think I have over 6,000 comic strips altogether between the 2 of them. I tried a while ago to build a recommendation engine within my own site that basically you could like a comic and it would recommend other comics I've made because, let's face it, 6,000 comics is a lot to read. I also wanted to make it even bigger and have my friends join. It'd be like, well, if you like this comic strip, you'll like this comic strip. And there was a lot of math. Like, that's actually a pretty hard problem to solve. Well, a lot of it is patent encumbered too, just for fun. So what Microsoft has done is extracted an entire recommendations engine. Now you can use it for, I mean, typically for something like a store, but also if you were Netflix, you could use something like this for, if you like this movie, you'll also like this movie. Specifically, it does, these things are frequently bought together. Customers who bought this item also, who like this item also like this item. And you, person with your buying history, we like to recommend this thing to you. So that's all boiled in. What you basically do is you upload your catalog and you upload the transactional data. And you can keep uploading new transactional data. Question? What's that? Does it rely on rating? I don't know if it relies on rating. There's some transactional data which is roughly maps to purchases. So for my purposes, I was gonna do it on rating. I was gonna treat a purchase like you liked something, and it would have the same effect. I think it's a binary, but I'm not sure. Okay. The rest of these are just about the Bing Search API, and I'll go through them pretty quickly. The core Bing Search API is essentially just an API for doing the thing you could do just to go hit Bing, and it's encumbered in the sense that when you display the results from this thing, You are required by the license to like display them in the same order and display all the information. There's not a lot of variance. They want you to show it like it would show up in Bing Search. They do not want you to become a competitor to Bing Search using the Bing Search API. But it's interesting. I mean, they're not going to make money because ads aren't part of it. But it's a API that costs money. And so it's interesting that they found a different way to monetize the same thing. And in my mind, a preferable way. More interesting are the image search, the video search, and to some degree the news search API. These are more targeted. The image search API is like, I want an image of a banana, right? And it'll get you pictures of bananas. You can also upload a picture of something, and it'll get you related images for that. You can upload an image, and it kind of does some cool image modeling stuff. Same thing for video, and also for news. And the last one is the Bing Auto Suggest API. This is the thing where I'm starting to type there, and it fills in the rest of it for me based on things that people have searched for in Bing. You know, the many billions or trillions of things people have searched for. It can fill that in for you. Cognitive services. So we have a couple minutes for questions. We got through it. And I would love to hear questions, and if anybody wants to talk about what they've done with stuff, I'd be interested in that too. Questions? The question is the recommendation engine the same as Azure Machine Learning? So machine learning is a general purpose toolkit for doing machine learning, and recommendations is a very specific model. What's that? Oh, okay, for recommendations. Okay, yeah, I don't know. I have to assume that they're closely related. What you're doing in the recommendation is actually training a model based on your data. So I assume it's based on that. Yep. That does not currently include the ability to add training data. If you think about it, they wouldn't want random people to be able to add data into the corpus as a whole. And so what you'd end up having to do is split off your own model, and that would get complicated and expensive. That's where you'd build your own model for stuff like that. Yep. Yep. It's available in several languages. Yep. Almost all of these things are available in several languages, and some of them quite a few. And that I don't know. That's a good question. Some of them are definitely locale specific. Some of them are English US, English UK, and some of them are really just English. So you have to look at the details. I wanted to say also that a lot of these things, for instance, Lewis was not available with a Japanese word breaker, and a big Japanese partner kind of contacted through DX and made a lot of noise, and we managed to move that to the top of the list. So if you're not getting, if there's something you need, it's a great idea to complain, especially to complain to someone in my group in developer experience, because we get to go to the product groups and say, this is a partner, they're blocked. They really need this, and sometimes that can materially change the way these things are ordered. Otherwise, they're just going to do it in whatever order they think is important. Yep.
Can you get quite far playing around with these things without having to lay down so much?
Incredibly far. Yep. Almost all of them, the free layers are more than I can imagine using. Yeah. Yeah. Not in front of putting in front of a big audience and stuff, but in terms of you playing with it, yeah. Usually, I mean, for example, I think like text analytics is something like 5,000 calls in a month, and that's a good number. And then it's not very expensive for the next level. These things really are pennies. They add up. We make money when people use them in the millions, but I guess it all adds up. All right, well, thank you very much. Fill this thing out. Appreciate it.